All right, y'all, new unit. So what we're doing today is we are going into graphing our trig functions. And so we are taking everything that we did in a unit circle, right? All of our values that we had on a unit circle. And now we're putting this on a coordinate plane where we have our x and our y axis. So this is kind of where we're going with all of this. Okay, so we're going to start with our parent function, just sine x. So if we want to graph this, we can make a table of values for this. And so we know this. This is going to be my angle, and this is going to be my function. And right now my function is sine x, so this is what I'm going to put here. So you can go back to your table, you can go back to your hand trick, whatever you do to find this, but we know that the value of sine of 0 is 0, and the sine value of 30 is 1/2. And 45 is the square root of 2 over 2, the square root of 3 over 2, the square root of 4 over 2, which is just 1. Okay, so we know those values. And so what we're going to do now, I'm going to turn these two numbers into decimals. And I know what these are. They're this is 7.07, so it's right at 7. And if I look at the square root of 3 that's divided by 2, that value is about 0.87, so almost 9. Okay, so what I'm going to do, I'm going to give myself a x-axis, because I'm not sure why it didn't print, but it didn't. And so what we have here is our y value. So remember, our y value here is my sine value, and this is my x, and my x value here is going to be my angle. So I don't have negative angles because remember, a negative angle just tells me the direction. So we're going to deal with just positive angles. And if I break this out, I'm going to say this is going to be 90, and then I have 180, 270, and then out here I'm going to do 360. Okay, so I've got my full circle, my angles, and then I'm going to break this out a little bit more and say, all right, this is 45 degrees, so I have 30 and 60 right here. And then this is 135. And so I have my two angles on the side of that. This one would be 225. So I'm just breaking this into 30, 45, and 60 in between each of these. Okay, so as I break this out, I've got these little minor angles here in between my big ones. My 0, my 90, my 180, my 270, and then back to 0 again, so I'm back to 360. Okay, so what I'm going to do is I'm going to take these points and I'm going to plot them on my graph. So first I have 0, 0. So when my angle is 0, my sine value is 0. And then at 30 degrees, hold on, let me put one more little line here. This is my 1, and here I'm going to have negative 1. Okay, so when I'm at 30 degrees, I'm at 1/2. When I'm at 45 degrees, I'm at like 0.7. When I'm at 60 degrees, I'm at 0.87. And when I'm at 90 degrees, I'm up here at 1. Okay, so now if I was to keep going around my unit circle, right, if I was to keep going, then I'm working backwards. So my next point here is going to be 0.87, and then 0.7, and then 1/2. And then when I get to 180, when I get over here, it's back to 0 again, so I have this point. Okay, so we just did our first quadrant, we did our second quadrant, now we're in our third quadrant, and we know that sine is negative in the third quadrant, and we know that sine is negative in the fourth quadrant. So I'm going to take the same values that I have, but now these values are going to be negative, just like they were negative over here when you see it represented as a circle. Okay, so this value now becomes negative 1/2. And then negative 0.7, negative 0.87, and then negative 1. And then I repeat it coming back up. So I'm in the fourth quadrant now. So I have negative 0.87, negative 7, negative 1/2, and negative 0. Okay, so I have all of these points. And this is not something that you're going to have to do. I'm doing this just because we're going to set this up so you see where these points come from. So now what I'm going to do is I am going to connect the dots on this. And when I connect the dots on this graph, uh-oh, my pen's not working. When I connect the dots on this graph, what you're going to see is that this becomes a curve. So I have this curved graph. The sine function always starts at 0, 0. It always ends at 360. Now, I can take these values because I know them, and I can put the radian values on here too. So I know that this is pi, and I know that this is 2 pi. So half of it is pi over 2. That's where I'm at 90 degrees. And half in between pi and 2 pi, I have 3 pi over 2. So 1.5 pi. Okay? So now what we're going to do, this is what your parent function for sine is always going to look like. So our sine graph is always going to be very flowy like this, and it's always going to start at 0, 0. Okay, so now we're going to put this in the calculator. So if we look at your calculator, we got to do a little bit of setup first. So the first thing that I want you to do is make sure that your calculator is in radian mode. It tells you that right here, but remember to go to radian mode. You hit mode on your calculator, and you're going to go down to radian and hit enter. Okay, now the next thing that we want to do is we want to graph sine equals yx. So we're going to go into y equals, and you're going to hit sine. Now, when you hit the x button, you're hitting this x that's right here. So we're going to do sine x. Okay, and then it gives us a window. So when we go to window, we want to start at 0. That's what this is telling us. We're going to start at 0, and we're going to go to 2 pi. So my maximum value, so this right here is going to be my max. My max happens at 2 pi. So watch how I plug this in. I'm going to literally type in a 2, and then I'm going to use the pi button. The pi button is right here at the caret. So you're going to do second caret, and that gives you 2 pi on your calculator. Now, when I hit enter, it's going to convert this to a decimal. So we know that pi is 3.14. So when we hit enter, now it just converted it to 6.28. Okay? So this tells us we want a scale of 1/2. Now, here's why. If we look at pi over 2, that's what we want our scale at. We see at pi over 2, we have this top point right here. This point in our graph we call our maximum. And then we have another critical point here at pi. We have another critical point here. This is where it turns back around. This point is my minimum. It's the bottom of my graph. And then we come back to this point and we have another 0 right here. So we see we have critical things that happen at pi over 2, pi, 3 pi over 2, and 2 pi. So we're going to make our scale pi over 2. So to do that, you're going to put a pi in just like you did a minute ago and then divide it by 2. Okay, now this also tells us that we want our y values, so that's my y min and my y max. So this is my y min and this is my y max, to be -3 to 3 and keep the scale at 1. Okay, so now I can graph that. Yay, so what we see is the same thing that we had up here. Okay, so when we put this onto a coordinate plane, this is what we're going to do right here. We're going to sketch this now in radians. So if this is in radians, I'm going to make my first line here pi over 2, and then this is going to be pi, this is going to be 3 pi over 2, and this is going to be 2 pi. So here's what we know. We know that we're always going to start at 0. I have another 0 at pi, and I have another 0 at 2 pi. Let's go back up here. I have a 0 here, a 0 at pi, a 0 at 2 pi. So this should be the first thing that you do when you graph this. You put your 3 zeros in. Okay, now we know we go up first on a sine graph, and so because that I have a maximum at pi over 2 and I have a minimum at 3 pi over 2. So my maximum is going to happen at 1, it's going to happen right here, and my minimum is going to happen at 3 pi over 2, which is right here. Now don't make this look like a shark tooth. This needs to be very curvy. It needs to be a curve like this. It's not straight lines. Okay. Now, the next thing that we're going to do, and this is what number 2 is down here, we're just going to do it right here. It's asking us to just make our window bigger. So we are going to now go from -2 pi to +2 pi. So if I look at this, if I'm going this direction, I still have pi over 2, pi, 3 pi over 2, and 2 pi. Now, when I go this direction, I'm going to use my same values, but they're going to be negative. So this is going to be negative pi. This would be negative pi over 2, negative 3 pi over 2, and negative 2 pi. All right, so when we sketch our graph, we are always going to go from left to right. Everything that we do, we're going to go from left to right. So I know that my zeros happen on all of my pi's, right? 0, 1 pi, 2 pi. So that means I'm going to have a 0 here at negative 2 pi. I'm going to have a 0 at pi. I'm going to have a 0 at 0. I'm going to have a 0 at pi and a 0 at 2 pi. So these are all of the times I'm going to cross the x-axis. Okay, so if I'm going to start by going up, and that's what the sine graph does. The sine graph starts by going up. That means that I go up here, and then I'm going to come down, and then I'm going to go up, and then I'm going to go down. If you remember, our first point was up. It was a maximum, so I went up, and then after my 0, I went down. So even though I'm not starting at 0, I'm starting at negative 2 pi, I went up first. But you see what happens when I get over here. When I get over here and draw this part of my curve, I see that it models what I had over here, even though technically I need to start at this point. And it's very smooth. Now, what you'll see when I graph these is that I usually don't end right on the 0. You'll usually see this little tail that comes because technically this graph is going to go on and on and on forever. So my domain on this graph, I'm just going to go ahead and write this here. It's going to come up again. My domain on a sine graph is always going to be negative infinity to infinity. It's just going to keep going forever and ever and ever. Okay? All right. Now let's talk about this. So what do you think would happen if our graph went from negative 4 pi to 4 pi? Well, that was kind of a lead-in to where we're at right here. So if I have pi, and then 2 pi, and then 3 pi, and then 4 pi, and I go this direction, so negative pi. What you're going to see happen is at every pi value, I'm going to have a 0. My scale is definitely wonky here. It does not look good. But what happens is every 0 I have a pi, and I know, every pi I have a 0, and I know my graph is going to go up to 1 and then down to 1 and then up to 1 and down to 1. And this cycle is just going to continue indefinitely. Right? If my scale was right, this would all be spaced right. So don't look at that. Okay? So here's what happens. Notice that the graph repeats itself every 2 pi units. Super important. So here's what I want to see. I start here at 0, and I do that much of my graph. Okay? That is 2 pi, from 0 to 2 pi. Well, guess what? I start again, and if I was to highlight this again, I would go from 2 pi to 4 pi. That's another 2 pi units. So what we say is that every 2 pi units, the graph repeats. So this is called a periodic function. And its period is 2 pi. And all this means is that it is going to repeat, or you can say start over. You're going to hear me say both. So it repeats and it starts over every 2 pi on my graph. Okay? All right, so now I'm going to do the same thing that I did over here with graphs 1 and 2, but now I'm going to do this using cosine. So if I was to go make a table, I'm going to just do this down here on the bottom. And if I look at this and I say 0, 30, 45, 60, and 90 degrees, and this is now going to be my cosine of x graph, I know that cosine of 0, if I go back to my hand trick, cosine of 0 is 1, and 30 degrees is now my square root of 3 over 2, 45 is square root 2 over 2, and then I have 1/2, and then I have 0. Okay, and we said a minute ago that this is about 0.8, and this is about 0.87. Okay, so if I go over here and I look at my graph, in fact, let me do one more thing here. We know that this is my pi over 2 value. And if I look at my cosine graph, I have all students take calculus. So I am going to be negative when I get into the second quadrant. So if I look at this from pi over 2 to pi, this is my first quadrant. This is what I have written right here. So at 0, my point now is 1. So now I'm going to start at this point 1. At 90 degrees, I'm going to be at 0, and that's my pi over 2 value. So if I look at these little values that I have in between here, I see that I start at 1, and I go down, and I go down, and I go down to 0. So we already know that our sine graph is going to be very flowy, and so is the cosine graph. So what I have is something that looks like this. I have this rounded arch like I have right here, okay? But what happens is when I get to the second quadrant, so this is pi over 2, and this is pi, when I get to the second quadrant, my cosine graph becomes negative. So now what happens is that my graph comes down, and when I get to pi, my cosine graph becomes negative. So this is my -1 value. If I was to keep going, and I have 3 pi over 2, and then 2 pi, my value here at 3 pi over 2 is 0, and my value here at 2 pi comes back up to 1. So my graph of my cosine function looks like this. And I kind of think about cosine looking kind of like a longhorn. If you think about it, I've got this longhorn right here, and that's kind of what I think about when I look at my cosine graph. Okay, so now I'm going to split this up, and I'm going to make this pi and 2 pi, and then I'm going to say negative pi and -2 pi. Okay, and what we have, remember my starting point at 0 is going to be the same at -2 pi, and so the cosine graph starts at 1. So I start at 1, and now every pi over 2, so this is -3 pi over 2, and this is negative pi over 2. These are my zeros this time. So here's my 0, here's my 0, and here's my 0. So it's opposite cosine zeros. Cosine zeros are opposite of sine zeros. Sine zeros happen on the pi value. Cosine values happen on the pi over 2 value. So really important. So my zeros are going to happen here on my cosine graph. So my negative, I'm going to come back up to positive, and I'm going to come back down to negative. So now when I connect this curve, there's my longhorn. So I did that one right. And now I do this one, and I come back up. So again, it's that same kind of graph where it's going to go up and down, and it's going to repeat in this same manner, but our starting points are different. Okay, so is the cosine a periodic function? Yes, it's a periodic function. It repeats. Remember, that's what we're saying. And how often does it repeat? It also repeats every 2 pi. Okay, let me grab the next page. So if I have this, the guidelines for graphing my sine x function is I have to remember that my graph has a period of 2 pi. And all this says is that it repeats or it starts over every 2 pi. So if I write this out, I have -2 pi, and this is negative pi, and then this one's pi, and 2 pi. So every other hash mark. Okay, because my opposite hash marks are going to be my pi over 2. Okay, so here's what I know. I'm going to ask myself these things. So the first thing I'm going to do is, where does it start? So my start happens right here. So this is my start. And then where does it end? So my ending point is going to be right here. The next thing I'm going to ask myself is, where is the halfway point? The halfway point is right here in the middle. So I have my start, I have my end, I have my halfway point. And now as I have this, I can look at every 2 pi. So I have my pi, this is a 2 pi, so I know this is an ending and this is an ending right here. So I'm going to go up and then down and then up and then down. And when I connect these dots, it's going to look like this. Okay, so here we are with cosine. My cosine, my period, again, is 2 pi. It's going to repeat. I'm going to have the same scale. So my scale is going to be negative 2 pi, negative pi, pi, and 2 pi. Okay, and you don't have to put all of the other ones, just put the pi in there. That's the one that's important. Okay, now let me go up here and do this. Let me add to this. So on our sine graph, we started at 0, we ended at 0, and then my halfway point here is also going to be at 0 because my period here, I'm doing so much of this. Okay, but you have to remember, I'm going to go up to 1 and down to negative 1. So this one's a little bit different, and that's why I wanted to do this. So we always, let's see, we're going to start my graph at 1. So negative 2 pi starts at 1. I'm going to end also at 1. So I'm going to end here at 1. My halfway point that I have for this graph is also going to be at 1. And then if I look at what's in between here on this, I know that at negative pi, it's going to be down here at negative 1. And at positive pi, it's going to be down here at negative 1. And then I'm going to put in my zeros. And my zeros happen at any pi over 2 interval. So this pi over 2 interval, this is a pi over 2 interval. It's 3 pi over 2, but I have this denominator of pi over 2. So I have a 0 here, and here, and here, and here. So now I can graph this, and it looks like that. Okay, so the takeaway on this lesson today is that these two graphs look almost identical, right? The zeros, they both go up to 1. They both have zeros. The zeros are in different locations. So the zeros here happen on the pi's. The zeros here happen on the half pi's. This graph always starts at 0. This graph always starts at 1. Okay, so our starting point at 1 versus our starting point at 0, and where our zeros is the other big takeaway. Remember that this has to be a smooth graph in between everything. Okay, all right. We're going to practice this in class, so go ahead and practice. You're basically repeating and copying everything that I just did on the other page.